Good afternoon, everybody. Welcome to this session where we're going to talk about a legacy .NET modernization and look at a case study. Agenda for today, we'll just start with quick introductions, and then we'll do some context setting around the business context. We'll then dive into the case study itself to take a look at how we've helped a customer with cloud application modernization on AWS. We're going to share our experiences, and then we'll jump into Q&A. So, quick introduction about myself. My name is Sambit Ghosh. I'm the Senior Vice President for Cloud Applications here at Datavail. I've been in the business for about 21 years in IT, across work mostly in the consulting and the IT services domain, across a variety of verticals over the years. Today, I work at Datavail, where we are helping transform the customers' businesses by taking advantage of the cloud and moving their legacy workloads to the cloud. So I'm hoping that we're going to share our experiences today, and it'll be beneficial to you wherever you are in your cloud journey. For those of you who don't know about Datavail, Datavail is a system integrator providing managed services and professional services. Been in the business for about 13 years, building and operating mission critical data and application systems. We have about 1,000 plus employees staffed in 4 countries, headquartered in Broomfield, Colorado. We have global delivery centers in Canada, in Toronto. We have 3 delivery centers in India, Mumbai, Hyderabad, and Bangalore, and we have a latest delivery center that we've opened recently this year in Bogota, Colombia. So Datavail has extensive AWS expertise that we have built over the years. We participate in a variety of AWS programs, be it the Aurora Optimization Program, the Babelfish Program, the Database Freedom Program, the Windows Rapid Migration Program, the Windows Modernization Program, and the Well-Architected Review Program, along with the Immersion Day Program. We are a service delivery partner with AWS for Amazon RDS, Amazon Aurora, AWS database migration services. We also work with AWS Redshift and DynamoDB migrations as well. From an offerings perspective, we offer a bunch of different marketplace offerings for AWS. Well-Architected Review, Amazon Oracle RDS Health Assessment Services, Amazon RDS Aurora for PostgreSQL, health assessment services, and we do some consulting and managed services offerings on MySQL and MariaDB, along with Mongo Health Check for AWS. And in terms of competency, we have Datavail has achieved the Windows workload competency. We have the Oracle competency and the migration competency in process, and we're also starting up on the data analytics competency. We have done this before in terms of migrations to the cloud with AWS. We've done about 150 plus successful migrations and modernizations for customers over the last 10 years. We have about 500 customers in our portfolio with an average lifespan of 7 plus years. Across the entire ecosystem of Datavail, we have over 100 plus AWS consultant certifications. And from a consulting consulting partner perspective, Datavail is an advanced tier consulting partner. Just a quick look at Datavail's cloud offerings. So Datavail's cloud offerings are focused on 4 pillars: applications, databases, data management, analytics, and enterprise applications. On the applications pillar, we assist customers with application modernization strategy and implementation, cloud native development, whether it's serverless, containers, or Kubernetes. We actually have an offering called the Sprint-based application development as a service, which provides the cloud native development in agile pods that can deliver, a backlog-driven, application solutions. We also provide application managed services for cloud applications, for applications both that we have built or that we can take over to help you run those applications from a KTLO perspective. And finally, with everything around applications in the cloud, one of the key aspects is DevOps. So we have an offering around DevOps strategy and implementation. From a database standpoint, we offer database migrations to the cloud, DB modernization strategies and implementations, database upgrades and performance tuning, high availability and disaster recovery strategies, along with database managed services and 24/7 monitoring. And then on the data management and analytics side, we do everything from data estate modernization, analytics roadmaps on the cloud, data governance in MDM, visualizations, data architectures based on business outcomes, and then we do cloud integrations and managed services. And then lastly, our focus on enterprise applications is with, on the Oracle stack that we provide both functional and application managed services on. And all of this, we deliver most of the offerings that we have that we just talked about on the cloud platform AWS. So specifically talking about our offering around modernizing legacy .NET applications on AWS, our offering is kind of divided into 4 pillars here. The first pillar is kind of where it all starts, cloud modernization assessment. And this is typically where we have services around discovery, planning and solution design, DevOps strategy, and business case. And once we have the discovery and planning and solution design completed, typically modernization of .NET, legacy applications entails either replatforming, be it containerizing it with Windows containers and with minimal code changes, implementing, CI/CD and infrastructure as a code for the replatformed application, and obviously leveraging, EKS or ECS or AWS Fargate in the replatform process. The more mature, option around refactor and rewrite is to embark on a cloud-native development with serverless, PaaS services or containers. Looking at .NET to .NET Core refactor, modernizing legacy monolithic applications, breaking them into microservices and refactoring the applications with microservices. And then for all of this, implementing DevOps, CI/CD, and infrastructure as a code. And then finally, containerizing these applications as Linux containers. And then, of course, we provide post-modernization application support, whether it's 24/7 KTLO services, application admin services, backlog-driven hotfix development, backlog-driven minor enhancement development, and QA and release management. So what are we covering in our case study today? If you look at the case study today, we're going to cover the customer context. We're going to cover the business drivers that led to the customer to embark on the modernization journey. We're going to cover the modernization roadmap itself and kind of look at what was the actual scope of the modernization. And then, talk a little bit about the planning and design stage, where we'll look at the architecture and design principles and considerations, along with target architecture and the AWS services leveraged in this modernization case study. So let's look at the customer for a minute. So this particular customer that we helped modernize their legacy .NET applications on was a healthcare organization that serves acute care hospitals in its network, provides several systems and services designed to support access to care for urgent, emergent, and critically ill patients who are being cared for within the acute care settings. Includes a 24/7, 365 case facilitation service for hospital-based physicians through a call center. Enables access to a hospital resource system, which provides an inventory of beds and resources available at hospitals in the network. So when you have the EMT, or ambulance picking up a patient, trying to figure out which hospital to take them to, they would use the services of this customer to determine what is the right hospital to bring the patient to with the right bed and the right resources available. Also, the customer enables hospitals to electronically initiate and track requests for patient repatriation from a higher to lower level acuity care hospital settings, so that whole patient transfer journey. And then lastly, operates on patient data system, which captures data on patient acuity and related resource requirements in all of the critical care units within the hospital network. So just taking a look at the customer's core legacy application portfolio, there are three kind of main applications. So there is the patient portal system, which essentially is tracking the patient status. It's capturing all of the patient's clinical data, tracking where they are in their journey through this hospital network. Then there is the hospital resources system that tracks the key resources of the hospitals in the network. And then finally, there is the integration engine that provides integration between the hospitals and the patient portal system as well as the hospital resource system. And the solution itself, just talking about the integration engine, there's about 100 plus hospitals in this hospital network. So there's a lot of data flowing between these hospitals back to the patient portal system and the hospital resources system. So if you look at the tech stack of the customer and their core legacy applications, right? So this particular customer, has different levels of maturity when it comes to the tech stack of their current legacy systems. If you look at the patient portal system, it's running the old ASP.NET Forms. The framework itself has been upgraded over the years to 4.6.1 .NET Framework and SQL Server 2014. It's about a decade, 15-year-old system when it was originally built, right? The hospital resources system is a little bit more recent. It's using MVC5 from a tech stack perspective. It's on .NET Framework 4.6.1, and it's using SQL Server 2017. And then the integration engine is built on top of BizTalk Server 2013 R2 and SQL Server 2014, and it's connecting with all of the different hospitals through a secure hospital network to interface with and collecting the data flow from those hospitals back to the customer. So a quick look at the architecture of the the overall legacy solution. It's a typical legacy .NET Framework based architecture. So you have the web servers that has the web services as well as the patient portal and the hospital resource portal. Right. If you see the box at the bottom, that's where all the SQL databases are housed. There's an integration database, the patient database, the hospital resources. And then on the far right is kind of where there's some ETL workloads happening to essentially build out the EDW and kind of then surface the data back as patient reports through a reporting server. So there is SSIS, SSAS, and just ETL happening as well as the SSRS reports. And then on the far left, you see the BizTalk server that's integrating through the the secure hospital network with the sites to receive the HL7 messages, and then it's feeding that information through the web services to the databases as well as to the patient portal. So what was the business case that drove the customer to consider modernization? So pre-COVID-19, of course, there was a lot of stress on the hospital anyways, right? But during COVID-19, it demonstrated the high priority that needed to be, put on ensuring that the existing healthcare systems of the organization, the hospital network, continue to meet the needs of the hospital network during the pandemic, right? There was a lot of burnout of the hospital staff during the pandemic, and there was a very, very glaring need for improved automation to reduce workload on the hospital staff, right? And at the same time, improve data quality, right? Because a lot of the sync between the hospitals and these systems that was so crucial to this service was still manual, right? And so real-time data became a high priority for this customer, making sure that they're using the newest and the latest and greatest technologies to build a sustainable system for the future with the ability to seamlessly integrate with future data repositories became of utmost importance. So first off, there's a need for the updates from the hospitals in order to provide a better service. the updates today in the legacy world were based on manual processes, right? And this impacted the quality of the service overall because, if you had more real-time data, you would not only reduce the workload on your staff, but you would also improve the quality of service. There was a desire to achieve real-time updates. That was kind of the end result. And then, all of this kind of presented an opportunity to modernize their current application portfolio for this customer. And that was kind of the business case to consider modernization of the current application, right? With the business case built, the customer engaged with Datavail to help put that the modernization vision to reality, right? And so we started the modernization roadmap for the customer with a journey that we typically do with most of our customers. So if you think about how we modernize legacy .NET applications with AWS here at Datavail, and I think a lot of you do as well, right? Discovery is kind of the starting point, right? So the discovery phase is where we would typically review the current state, look at the application in question, look at the current architecture, look at the code availability, understand the business drivers for modernization. Now, we talked about real-time data here, but there were other drivers, and we'll talk about that in a minute. And then kind of, leverage tools like the reporting assistant and others to kind of understand what that potential jump from .NET to .NET Core would be if that is one of the considerations. Look at the high-level code and migration needs analysis, review the CI/CD current state, and kind of starting to understand the business, the current state technology, as well as the maturity of the application to help define the modernization strategy, whether it's replatform, whether it's refactor, whether it's a rewrite, right? Refactor can contain a rewrite as an option. So the idea was to figure out the right strategy for the customer, whether it's to containerize the application, whether it's to refactor to .NET Core and then containerize it using Linux containers, or refactor to microservices and build it from ground up, right? So there were different options here, and we explored typically all of that in the discovery phase. And from there, we kind of dive into the planning and solutioning phase, which kind of results in a final target state architecture and an implementation plan, communication plan, and test cases. And from there on, we move on to the implementation of the modernization and migration phase, following which there is the post-modernization and migration support. So typical drivers for application modernization that we see that we typically will include in our discovery process with every customer. We're looking at the drivers that they're engaging in potentially could be speed of innovation, improved DevOps, could be around license freedom and cost savings. All right, if you get rid of all the Windows licenses, move from .NET to .NET Core, that could be significant savings if you're running it on Linux containers. Then you have the customers' potential drivers for performance and horizontal scaling. That could come with using a microservices-based architecture, using some of the cloud-native PaaS services, using auto-scaling. It's available in the cloud. Of course, less management overhead is sometimes a key driver, and then overall need for better performance. Just moving from .NET to .NET Core sometimes can provide that boost. And then, of course, if you're moving on from a Windows-based solution to Linux containers, it's much lighter and faster at that point. So that's typically the drivers. And then, the drivers would result in the 6 Rs, as we call it, right? So whether it's a rehost, replatform, refactor/rewrite, or a repurchase, retire, or redeem. So in this particular case study with the customer, the business drivers for cloud modernization, as we started to go down the discovery path and dig deep under the hood, there was obviously, we talked about this one in the business case, the need for real-time updates to the data versus current manual processes for data updates from the network hospitals. Many times these updates were being delayed, and that was kind of resulting in inaccurate state of the data at a later point. But then other than that, there was a few other business drivers discovered and uncovered during the discovery process, like spending significant funds annually in maintaining the infrastructure, the aging infrastructure. That was a big spend. So the customer was spending to the tune of I think $1 to $1.2 million annually in maintaining its aging infrastructure, and they wanted to reduce that high level of infrastructure technical debt, right? And there was also, just application technical debt in terms of the ability to release, new features with nimbleness, right? So, the desire was to move to a faster go-to-market with a more modernized cloud-based solution, and that would provide the ability to innovate quickly, but with high quality, right? Apart from that, there was a desire to reduce the spend on refreshes of infrastructures and licenses in the current, legacy world, where every so many years later there was an upgrade done, either for the framework or for the OS or for the database, and things like that, right? So that was incurring significant spend, on the on-prem world, and some of that would be alleviated moving to the cloud. And then lastly, there was a desire to move away from managing infrastructure, period, and kind of take all these savings from reducing spend on the infrastructures, reducing spend on the refresh of the infrastructure, license freedom, and kind of invest those savings into funding future innovations and providing cutting edge healthcare to patients, right? And then lastly, there was another additional driver that really came up during the discovery. It wasn't in the original conversations, but it kind of evolved. That the patient portal solution, there was a desire to really upgrade the business functionality of that entire application, and also the user experience. There was a desire to really, really upgrade it to the next level, the cutting edge user experience, and move off the experience that the current ASP.NET Forms provided, right? So with all of that, if I look at the desired outcome of the cloud modernization that the customer was looking for, there was a desire to improve the updates to the data from the hospitals and achieve a more real-time update versus the more manual updates today. There was a desire to lower the cost of operations overall. There was a desire to reinvest cost savings into delivering more business value to the patients and hospitals. There was a desire to improve agility to deliver new business features and thereby unlock business value faster with the modernization of the application portfolio, and also because it's all containerized and it's providing better isolation. There was a desire to get increase in the quality of releases and also improve security as well as the business features and user experience for the patient portal, as I talked about. So taking all of this together, as we kind of went through the drivers and the business drivers and the asks of the customer as we're looking at the modernization strategy, definitely we advise the customer to look beyond lift and shift, and kind of start exploring options around replatforming, refactor, and rewrite, right? So see, we kind of went through that journey with the customer and just kind of explored the different options like rehosting options on AWS, which we didn't recommend. We recommended them to replatform and obviously refactor and rehost or rewrite. So deploy to EC2 or deploy to Elastic Beanstalk. These are typically the rehost options. If you look at the replatform options on AWS for .NET legacy applications, you can containerize to Windows containers, use tools like apt-container to help you do so, and you can deploy those containers to either on ECS or on EKS or on Fargate, right? And then we looked at the refactor option on AWS, which typically entails refactoring the .NET legacy framework to .NET Core, and then containerizing it to Linux containers, right? And so that can be again deployed on ECS, EKS, Fargate, and Fargate with Kubernetes. So looking at those options, we also looked at refactoring to .NET Core and deploying everything on Beanstalk and Lambda. And finally, after looking at the different sort of options, our recommended approach to the customer was, let's look one by one. So the patient portal system, we recommended that they upgrade its current business functionality to next gen of features and functionality. They focus on improving the user experience. So we recommended to rewrite that application from ground up, build it with in cloud native in .NET Core, .NET 5, or .NET 6 as well. Now that it's out, but when we started this, it was .NET 5. Containerize the application with Linux containers on AWS Fargate. We recommended the hospital resources system to upgrade keep the current functionality. So there wasn't a demand for changing the functionality in the immediate future. They were happy with the functionality. So we recommended that this application be refactored to .NET Core and .NET 5 from its current state, and then containerize it with Linux containers on AWS Fargate. Now, one thing I want to say here is a portion of this solution was also going to be carved out. The one that dealt with the transferring of patients, it was kind of carved out as its own solution. And the recommendation was to just take that carved out solution in the .NET framework, and there was not a lot of desire to, refactor it to .NET Core due to some complexities as we had looked during the discovery phase. So we were going to carve it out and then essentially containerize it to Windows containers with Active Container and kind of run it as a Windows container application, right? And then lastly, the integration engine, next-gen business functionality to support the desired real-time data updates. So we recommended a rewrite and leverage, a more real-time data integration engine and architecture to drive the desired outcome. So with that, I'm going to dive a little bit into the planning and design. So once we jumped into the planning and design and kind of having the high-level approach, the modernization approach, we leveraged the AWS Well-Architected Framework based approach. So looking at the different pillars: operation excellence, security, reliability, performance efficiency, cost optimization, and sustainability. And we started looking at each of these pillars, looked at the key design principles that the framework recommends, and then we kind of started documenting our design considerations and kind of having conversations around that. So, for example, on the operational excellence, looking at the key design principle around performing operations as code, we decided to leverage the AWS CDK, the Cloud Development Kit, to deploy all infrastructure artifacts and kind of taken everything as a code approach, right? We also decided to address the frequent but small reversible changes by taking that everything as a code approach, DevOps and infrastructure as a code, along with a microservices based approach to kind of build very purpose-built services, to allow for ongoing changes and kind of allow for deployment on demand. Our automation-driven approach would allow for ongoing incremental improvements, from an operational perspective, anticipating failure. So, we leverage CloudWatch, one of the services from AWS, and kind of just in principle wanted to, have logging, monitoring, and alerting embedded into our solution. And then, of course, one of our core design consideration is to always perform root cause analysis in terms of failures and learn from our operational failures. So key principle, right? From a security standpoint, we leveraged the directory services in AWS IAM to implement a strong identity foundation. I already said that we talked about CloudWatch. So using it for logging, monitoring, alerting allowed us to do some traceability in our solution as well. All connectivity was maintained and kind of developed via infrastructure as a code. So we automated the security best practices, like kind of built everything from a code perspective that was traceable, that was tangible, and any kind of changes was going through a proper governance process. Protecting data in transit and at rest. So that was, some of it was provided by Aurora DB and S3. So we used Aurora MySQL for this solution, and obviously S3 for storing data. And then we use VPN and HTTPS. So a part of that also contributed to protecting the data in transit and at rest. And then, of course, keeping people away from data. We used infrastructure as a code, like I said, so everything was, built as a code, leveraging the cloud CDK or the AWS CDK. We used the secrets manager, so nothing was kind of, hand coded or accessed. And then preparing for security events, we actually used CloudTrail in our solution for, diagnostic of, any kind of anomalies in the security events standpoint. From a reliability standpoint, automatically recover from failure. So our approach was using, obviously serverless capabilities, Lambda, ECS, and it allows, self-healing, scale horizontally to increase aggregate workload availability. Again, we used multiple resources across multiple environments and multiple applications. So every environment was carved out cleanly into different, AWS accounts and kind of distributed across different, AWS, environments and availability zones and things like that. So we use multiple, AZs to kind of improve the resiliency of our solution. We stopped guessing capacity, so nothing in our solution was guessing the capacity. We were using, everything that was allowing for elasticity from a cloud perspective and taking advantage of that elasticity provided by the AWS services. And then, of course, manage change and automation. So all of the, AWS CDK, using that to deploy all infrastructure artifacts, having it, uh, controlled by source code, managed, right? So it was all versioned and properly controlled. Performance efficiency, we leveraged, like I said, SaaS as much as or PaaS as much as we could. We use serverless architectures and we, experimented more often, particularly because we had everything as a code. From a cost optimization perspective, we kind of laid the base foundation for, account, like I said, we isolated AWS account level isolation, right? Like in terms of the different environments to enable cloud financial management in the future. We used obviously, PaaS and serverless as much as we could to optimize cost. And then, our separation of the AWS account level isolation allowed for, a foundation to analyze and attribute expenditure in the future, stop spending money, on undifferentiated heavy lifting, as well as measure overall efficiencies. From a sustainability standpoint, again, because we used, PaaS and serverless, we really, allowed for maximizing utilization of resources and using managed services. So now jumping a little bit into the target state architecture of the solution, of the patient portal and the hospital resource solution. So the hospital resource system was refactored to .NET 5, actually. It's a 6-year, it's the latest version, but when we started this, it was in .NET 5. The patient portal was rewritten from ground up with .NET 5 as well. The use of standard HL7 messaging integration was done with AWS Mirth to kind of support that need for really real-time automated data integration. Target state also leveraged the Amazon Aurora MySQL for database purposes. And also leveraged ECS and AWS Fargate for the portal and the backend microservices. And the target state leveraged Lambda and CloudWatch events for any kind of scheduled jobs. So if you look at the architecture diagram, and I know it's a little bit hard to read, the core of the solution that was refactored into .NET 5, .NET 6, and containerized would be running, as ECS tasks that we see right here, right? And then, as kind of I mentioned earlier that from a security standpoint, we were using directory services and AWS IAM for kind of access control and security. And then we used, Aurora MySQL for the database. On the left-hand side, as we can see, this is kind of where the hospitals are sitting here, and then they're coming into a secure network that we connected to our AWS environment for the customer. And we used Direct Connect to create that initial, connection through that secure network. And then we used, Transit Gateway to connect the merged solution that was in itself also a containerized solution with Amazon ECS tasks. It was running as Amazon ECS task as well on AWS Fargate. And we were leveraging the Transit Gateway to kind of map the integration endpoints to the variety of hospitals on the other side of the network. A deeper look at the integration solution itself. The healthcare data integration solution leveraged AWS and Mirth Connect to address the real-time data problem that they wanted to solve. The solution utilized HL7 messaging standard. The use of HL7 standard messaging integration via AWS and Mirth provided the ability to connect all these hospitals and provide that real-time automated data entry. The high processing capabilities of AWS and Mirth facilitated the real-time data update as was evident in the need from the customer in the business case when HL7 messages were sent through the hospital interfaces. And then running Mirth Connect on AWS provided the necessary scalability and elasticity to meet not only the current needs, but also the future need of this hospital network. And as they added more hospitals over the years, it would scale, effortlessly and in a way that is cost efficient, right? So overall, from a solution perspective, the integration solution provided HL7 message support. It allowed for performance to scale up. It was, using obviously on the back end of it, Amazon SQS and Lambda to process the messages in sequence. And the solution was kind of architected in a high availability manner with multiple lazy failover and a network load balancer. From a security perspective, like I said, Aurora database, security features were leveraged. We use directory services and IAM for securing access to the database. From a networking perspective, site-to-site connection with each of the hospitals was kind of part of the design. And AWS Direct Connect to connect between AWS and on-prem data center for dedicated high-speed connection. So just kind of summarizing and looking at all the different AWS services that were leveraged in our future state architecture, in this particular case study. From an infrastructure networking perspective, we leveraged obviously virtual private clouds, Amazon VPCs. We leveraged Amazon zones and subnets. We leveraged Route 53 for discovery. We leverage, application load balancing and direct connect and site-to-site VPN. From a web portal services perspective, we used, a .NET Core, .NET 5.6 API, web API. We used the front end was React. We used Docker containers, and we used Amazon Elastic Container Service that was running on Fargate. From a scheduled jobs perspective, we used the CloudWatch events, and we used AWS Lambda. Again, to summarize, integration engine was built with AWS Mirth Connect on ECS and MySQL Aurora. We used AWS Lambda, we used Amazon S3, we used application load balancing and web API for the integration engine. For data management, it was Amazon Aurora, MySQL, and Elasticache. We use Glue for the ETL piece of the solution, and then we use S3, for storage. So again, Looking at the notification, we use, simple notification service for some business features in our application. We use Amazon Athena and QuickSight for the reporting. And for the identity and access, we use the directory service and the identity and access management, the AWS IAM. So just kind of to summarize, with our learnings and best practices from this particular journey in helping our customer modernize their aging legacy .NET applications to the AWS cloud. Couple of things I would say. If you're embarking on a journey to modernize your applications, I would say make use of the AWS Well-Architected Framework. It's a very helpful framework to make sure that you're taking advantage of the architectural best practices for designing and operating reliable, secure, efficient systems in the cloud. Where possible, refactor to .NET Core, .NET 5, .NET 6, where possible, and retire technical debt. When not possible due to constraints, maybe you don't have the source code, maybe it's not possible to refactor. Consider at least containerizing it to Windows containers versus a pure lift and shift. Because the moment you do that, it gives you some benefit right off the bat, and you can start also getting some DevOps benefit if you're not already using that in your on-prem solution. Leverage, cloud native serverless and PaaS services whenever possible to get the most out of cloud modernization. Everything as a code, as I mentioned a couple of times, is key. So leveraging infrastructure as a code to automate all provisioning and deployments. Make use of the availability zones to improve the availability and the reliability of your solution, making sure it's really available all the time. Plan for logging, alerting, and monitoring from the get-go. Don't let it be an afterthought. Isolate your environments within multiple AWS accounts to improve security cleanly. And don't forget to modernize your database as well as you're looking at modernizing your applications. That's all I had for today. We'll jump into the Q&A, but I've kind of put my contact information out here. Should you need any more details about any of the content that I presented today, I'll be happy to do so and kind of get back to you with any more details that you want to share. Thanks a lot, and have a wonderful afternoon.